Hello and welcome. Today, we're going to pull back the curtain on one of the key technologies that's really, secretly powering this whole AI revolution. It's called a vector database, and it's basically teaching computers to understand information not just by keywords, but by meaning. So let's dive right in.
Okay, so let's start with a super common problem, one I'm sure you've run into. You're searching for things to eat, but you get nothing. Why? Because you didn't type the exact word food. The reason this happens is that traditional databases are incredibly literal. They're just looking for an exact keyword match, not the actual meaning behind your words. So if it's not a perfect match, you get zip.
And this slide just shows you the difference in a nutshell. A traditional search for something like kongkin, or things to eat, fails because it doesn't understand that it means ahan, or food. But a vector search? Oh, it totally gets it. It understands the context, the semantic meaning, and serves up the right result. This is the huge leap we're talking about.
So, how do we get this much smarter search? Well, the answer is the technology right at the heart of this explainer, the vector database. You can honestly think of it as AI's secret weapon. It's what allows all these new applications to finally move beyond simple keywords and start to understand context, kind of like how a person would.
So what even is a vector database? Well, put simply, it's a special kind of library, but it's built to handle a unique type of data called vectors. Now, these aren't just random numbers. They're actually rich numerical fingerprints of really complex stuff. Things like text, images, and even audio. Think of it as a library organized by meaning, not just by words on a page.
So how is this different from a database that you might be more familiar with? Well, a standard database is kind of like a perfectly organized spreadsheet. It's fantastic for finding exact matches, like a customer's ID number. A vector database is a whole different ballgame. It doesn't look for what's identical, it searches for what's closest in meaning. It uses this clever technique called approximate nearest neighbor search, which I know sounds complicated, but it's really just a fancy way of saying it finds the best possible match super quickly, without having to check every single thing. It's built from the ground up for similarity, not just identity.
Okay, this all sounds pretty cool, but how in the world do you actually turn a picture of a cat or a paragraph of text into a big list of numbers? That, my friends, is where the real magic happens. So let's break down that process.
This whole process has a name. It's called vector embedding. Basically, you use a special kind of AI model that acts like a universal translator. You can feed it pretty much anything, a block of text, an image, even a song, and it converts it into that numerical fingerprint we talked about, a vector. And that vector is what captures the core essence, the meaning of the original data in a language that computers can actually understand and compare.
It really just boils down to 3 simple steps. First, you get your data ready, your text, your images, whatever. Second, you run that data through an embedding model, which is the part that does the translation into vectors. And third, you store those brand new vectors in your vector database, where they're all ready to be searched. Simple as that.
And here is the absolute key takeaway. In this digital world, this vector space, distance actually means something. Things with similar concepts like the word cat and the word kitten get placed really close together. Meanwhile, unrelated things like cat and car are way far apart. It's a simple but powerful idea. Proximity equals similarity.
All right, so now that we've got a handle on the how, let's get to the really exciting part. What can we actually do with this stuff? Let's take a look at some of the incredible applications being built on this technology as we speak.
The applications here are just incredible, and they all pivot on that one core idea of similarity. You've got Semantic Search, which finds documents based on similar meaning. Recommendation systems suggest movies by finding users with similar taste. Anomaly detection can spot a credit card transaction that isn't similar to your normal spending habits. It even powers multimedia search, letting you find images that are visually similar to another one.
But honestly, maybe the biggest, most game-changing use case right now is something called Retrieval-Augmented Generation, or RAG for short. In a RAG system, the vector database acts like a specialized long-term memory for an AI like ChatGPT. This lets the AI tap into your private company documents or the very latest data, so it can give you answers that are not only accurate but also totally specific to you and your world. It's a huge deal.
Okay, but like any technology, it's not a magic bullet. It's not the perfect solution for every single problem out there. To really get it, we need to take a clear-eyed look at both the good and the bad, the advantages and the limitations.
So the upsides, they're really powerful. At its core, you get this amazing similarity search across literally any data type you can think of. These systems are also built to scale so they can handle billions of items without even breaking a sweat. And of course, they're the engine for next-gen AI like RAG. What's even better is that new hardware like GPUs is making them faster and more efficient every single day.
But there are definitely real trade-offs to consider. Using a managed service can get pretty expensive, and trying to host it yourself requires some serious technical skills. You'll need a good DevOps team. And this is a big one. Your results are completely 100% dependent on the quality of your embedding model. It's a classic case of garbage in, garbage out. And critically, these databases aren't for everything. They're never going to replace your bank's database, for example, because they aren't built for transactional data that needs perfect, ironclad consistency.
Now, the landscape of tools out there is growing really, really fast. You've got super easy-to-use services like Pinecone, which is just perfect for startups trying to get going quickly. Then you have these powerful open-source options. Weavia is amazing for handling really complex data with lots of metadata, while Milvus is an absolute performance beast, built for massive enterprise-scale projects. The right choice really just depends on what your team needs to accomplish.
So when you take a step back and you put all of this together, what does it mean for the bigger picture? How is this going to change the way we find and interact with information in the years to come?
You know, ultimately, this isn't just some small incremental improvement. It is a fundamental shift. We are moving from simple databases of record to powerful new databases of understanding. This technology is really what's paving the way for more intuitive, more intelligent, and frankly, more human-like ways to interact with all of our data. And that kind of leaves us with a pretty fascinating question to ponder, doesn't it? We're building systems that can understand context and see relationships in ways we've never seen before. So as this technology gets more and more sophisticated and AI starts to grasp meaning on an even deeper level, how is that going to reshape our world? It's definitely something to think about. Thanks so much for joining me on this explainer.